Hi friend, you are welcome back to Physics Academy. And in today's video class, we'll be talking about the topic called oxidation number. The purpose of this class is for us to know how to find the oxidation number of an element in a compound. So without wasting time, let's get started. Now first thing first, common oxidation number. We have to know the common oxidation number for the first 20 elements. Alright? For hydrogen is +1, for helium it's 0, for lithium is +1, beryllium is +2, boron is +3. Carbon can vary, it's either a +2 or a +4. For nitrogen, it ranges from -3 to +5, depending on the compound it's found in. Then for oxygen, it's usually a -2. Fluorine, it is -1. Then in neon, the oxidation number is 0. For sodium, it's +1. For magnesium, it's +2. Aluminium, it's +3. Then for silicon, it's either a +2 or a +4. Now for phosphorus, it varies. It's from -3 to what? +5, depending on the compound. Sulfur, it also varies. It's from -2 to +6, depending on the compound. Then for chlorine, in most cases, it's a -1 in almost all compounds. But in some special compound, chlorine can also vary. So I said -1 to +7. Now argon is a noble gas. Same thing as neon, same thing as helium. So because of that, they have a complete outermost shell, so they don't have need for oxidation number, so theirs is 0. Now for potassium, it's +1. Calcium is what? +2. Now observe something, that for the metals of the first 20 elements, they have just a single oxidation number. Example, you have lithium. Example, you have beryllium. Example, you have boron. Example, you have sodium, magnesium, aluminium. Okay? Potassium, calcium. All these are the metals of the first 20 elements. These guys have just a single oxidation number. So when you are asked to find oxidation state of an element in a compound, they most times don't specify for these metals because their oxidation state is constant. So that at the back of your mind, let's get to this side of the board. I said the rules for finding oxidation state. You could be given a question to find what is the oxidation state of chlorine in a certain compound. What is the oxidation state of nitrogen in a certain compound? How do you go about it? That is what this part of the board will help us to know. Now the first step or the first rule is that the oxidation state of any free element or a pure element is equivalent to 0. So if you ask what is the oxidation state of gaseous oxygen? Oxygen in its gaseous state is pure form, is it not? That's the free form of oxygen. It's gaseous in nature. Now, on a norm, it's 0. So O2 has an oxidation state of what? 0. Another example is hydrogen gas. It has an oxidation state of what? 0. Another example is sodium. Now, sodium is a melter and is monoatomic in its free state. So therefore, what is the oxidation state of free sodium? The answer is what? 0. Phosphorus in its free state is P4, that means it's tetraatomic. So if you're asked to find the oxidation state of free phosphorus gas, it's what? 0. So it applies to every other element of the periodic table. So moving on to the next rule. For monoatomic ions, these are ions that is formed by a single atom or a single element. Example is sodium ion, chloride ion, nitride ion, then you have magnesium ions. These guys are carrying charges, is it not? Here it is +1, here it's -1, here it's a -3, and here it's a what? A +2. So if you were asked to find the oxidation number of, let's say, sodium ion, the answer will be equivalent to the charge, and in this case, the answer is what? +1. Let's say for nitride ion, the charge here is -3, okay? So the oxidation state of nitride ion is what? -3. For magnesium ion, it will be what? +2. Now, what's the next rule? Now, if you are asked to find the oxidation state of a certain element in a neutral compound, emphasis on neutral compound, what will you say and how will you go about it? There is a rule to use, and the rule is that the sum of the oxidation numbers of all the elements in that neutral compound should be equivalent to what? 0. So when you are adding up the individual oxidation number of the element, you should equals it to what? 0. That is the rule. Now, if it was a polyatomic ion that the element was found in, let's say find the oxidation number of nitrogen in nitrate ion. Nitrate ion is a polyatomic ion because you have oxygen and you also have nitrogen. So what do? The rule to use is that the sum of the oxidation states in that polyatomic ion should be equal to the charge. So whatever the charge of the polyatomic ion, you should equals the sum to it. Don't worry, when we start taking question, we will understand better. So now guys that we have this at the back of our mind, without wasting your time guys, we'll be taking some questions on finding the oxidation state, which is the same thing as finding the oxidation number. So let's have the questions now. Alright guys, here are the questions we are asked to solve under oxidation number. The question reads, find the oxidation state or oxidation number of first question, sulfur in X8. Number 2 is nitrogen in nitride ion. Number 3 is chromium in K2CrO2O7, that is potassium heptaoxochromate 6. We are asked to find the oxidation number of chromium in it. Then this is for what? P in PO4 3 minus. So let's see how we can solve this question under oxidation number. So we're taking the solution here. Alright? So let's get started. Now for the first question, it reads sulfur in X8. Now this is sulfur gas. Sulfur in its free state is X8. That is 8 atoms of sulfur will come together to form a sulfur molecule. And that's how sulfur occurs normally in its free state. X8, X8. So, because this is a free molecule of sulfur, or this is a pure form of sulfur in its natural form, it therefore means that the oxidation state of sulfur in X8 is equal to what? 0. There is no need to solve this question because this form of sulfur is the free form. So simply the answer to this question is that X is equal to what? 0. That the oxidation state of sulfur in this compound, in this molecule, is what? 0. Now for the next question, they said number 2, N in N raised to power 5 minus. Now this is an ion. This is what? An ion. We are asked to find the oxidation number of nitrogen in it. Now observe that this ion is carrying a -5 charge. And how many elements are you seeing in this ion? Just a single atom or a single element, right? Now because this ion is having a single atom, we say it's what? A monoatomic ion. Now because that is the case, what is the rule under oxidation state when dealing with monoatomic ion? The answer is that for monoatomic ions such as this, the oxidation state of the elements in it is equivalent to the charge. So the oxidation state of nitrogen in N raised to power -5 is the charge. And what is the charge here? The charge is what? -5. Is it not? You call the sign before the number. So the answer is what? -5. Now next question, they said CrO in K2CrO2O7. So this one will involve a long process. Let's get started. CrO in K2CrO2O7. Now observe something. This is the compound. We are asked to find the oxidation number of chromium in it. Looking at this compound, is there a charge? No charge. So this compound is neutral, true or false? So this is an example or a case of what? Neutral compound. Now what is the rule when dealing with neutral compound? The sum of the oxidation state of the individual elements in it should be equivalent to what? 0. Reason being that the compound is carrying what? No charge. So how do we solve this? What is the compound? You have K2CrO2O7. In this compound you have potassium, you have chromium, and you have oxygen. So when we sum up their individual oxidation states, we should equate it to what? 0. This is how you do it. K2CrO2O7. Now in this compound, how many atoms of potassium? You are seeing 2 atoms of what? Potassium. Is it not? Plus, how many atoms of chromium? You are seeing 2 atoms of what? Chromium. How many atoms of oxygen? You are seeing what? 7 atoms of what? Oxygen. It should be equal to what? For neutral compound, we should equate it to what? 0. Good. 0. So you put here 0. Now you have succeeded in expressing it out. Now each of these elements, K, CrO, and O, we will be replacing it with their common oxidation number. We'll be replacing them with their what? Common oxidation number. Now mind you, that for chromium is what we are looking for. So we'll leave it the way it is because we don't know it yet. Is it not? Good. So it will now be 2 times the common oxidation state or the normal oxidation state for potassium is what? Plus 1. Is it not? Added to another bracket 2 times, we don't know for chromium yet, so we leave it as CrO plus 7 times that for what? Oxygen. In most cases, what? Minus 2. So this is what we have. It will now be equal to what? 0. So let's continue solving. 2 times plus 1, it will be what? Plus 2. Because the only sign here is plus, and 2 times 1 is what? 2. Plus 2 times 2CrO, let's just say 2CrO, okay? Plus 2 times 7 times minus 2 is what? Bracket minus 14. So this is what we have. It will now be equal to what? 0. So now we have this. Let's do something very strategic here. This plus 2 is the same thing as 2, right? Plus 2CrO, okay? 2CrO. Now, plus times minus is what? Minus. So it now be minus 14 equals to what? 0. So this is what we now have. So what do you now do? You collect like terms. You collect like terms. All the what? We can choose to, let's group this together. Or let's take to the other side of the equation. It will now be, remember we have 2 plus 2CrO minus 14 equals to what? 0. So because this is the CrO we are looking for, we'll leave it on this side. We'll leave this 2CrO on this side. 2CrO, it will now be equals to, so let's move 14 this way, minus 14. When you move it this way, it will become what? Plus 14. Is it not? Then when you move plus 2 this other way, it will become what? Minus 2. Is that correct? So this will now be 2CrO equals 14 minus 2. It will be what? Plus 12. Mind you, when it comes this way, it will become plus 14. Is it not? So now you have 2CrO equals plus 12. What do you now do to make CrO subject? Divide both sides by what is attached, which is what? 2 over 2 over 2. 2 will cancel 2 here. You have CrO equals 2 in 12 is what? Plus 6. So the oxidation state of chromium in K2CrO2O7 is what? Plus 6. I think that is it. I hope you can now understand how these questions are solved. So let's do this last one on this part of the board, okay? Let's do it on this part of the board. Now for the number 4, we are asked to find phosphorus in PO4 3 minus. So P in PO4 3 minus. So I will put the radical here, PO4 3 minus. Now ask yourself, is there only a single atom in this ion? The answer is no. There are more than one atom in this ion. So this is a polyatomic ion. And the rule for polyatomic ion is that the sum of the oxidation number should be equal to what? The charge. So how do we now expand this? How many atoms of phosphorus are you seeing? Just one. Okay? Added to how many atoms of what? Oxygen are you seeing? You are seeing 4 atoms times O equals to, because it's just these 2 elements. What is the charge? Minus 3. Alright? So P plus, let's expand. 4 times the common oxidation state of oxygen is what? Minus 2. It should be equal to what? Minus 3, which is the charge. Working it further, this should be 4 times minus 2 is what? Minus 8. So plus minus 8 equals minus 3. Now watch out. Plus times minus is minus. So this is what we now have. Equals minus 3. Okay? Now let's move this minus 3 this way. To be P equals to minus 3 plus 8. Because when minus 8 cross this equality sign, to become plus. So we can expand this further, bringing the positive 8 to the front. 8, taking the minus 3 to the back, minus 3. And 8 minus 3 is what? 5. So we'll say plus 5. And that is the answer to the question. So guys, I clearly hope you understand how questions on oxidation number are being calculated. So about now, I'll be dropping some calculations for you guys to try your hands on. let's have them now. Alright guys, here is the question you are asked to try your hand on. Find the oxidation number or state of oxygen in ozone. Ozone is O3. Observe there is a charge. So you have to look for the oxidation number of oxygen or O in what? Free ozone molecule or pure ozone molecule. Now the next one is for you to find the oxidation number of aluminium in aluminium ion. This is the charge. Now the next way to find the oxidation number of sulfur in H2SO4. And observe this is not carrying any charge. So this is a what? A neutral compound. Why this is a what? A monoatomic ion. Now the last one is find the oxidation number of nitrogen in NO3 minus. Now observe that there are more than one atom in this ion. So this is a what? A polyatomic ion scenario. So do have to try your hands on this question, and feel free to let me know what you think the answer to these questions is in the comment section. Don't forget to share my video with your friends. Thanks for watching. I remain Diffusar. See you in my next video.